Okay, so this is lesson 18, and I'm actually going to throw in 19 as well, just to, it's pretty short, but we're covering new stuff. So just to refresh your memory, we can take a carbonyl group and we can make acetyl. So those are great for protection groups, right? So the same way you can do that, you can actually remove the protection group through what's known as hydrolysis. So you're adding water across here because you got 1 oxygen and 2 hydrogen. So that's where the hydrolysis comes in. And that's where we're making the C-double-O bond again, right? So let's see. You can do that also with amines and enamines by using acidic water, and you end up with a carbonyl group in both cases, which is a little bit harder to see in this case, but same thing is going to happen there, which is kind of neat because you can do different stuff with that as well. In a similar fashion, you can actually make a thioacetal by using a dithiol. I think that's how you would name it. So where the thiol here, it works just like the alcohols do, and you end up making 2 bonds to sulfur. Now the cool thing here is that you can actually use Ronnie nickel to make it go to an alkane. Well, that's advantageous because you can actually now take that carbonyl, something that you would get a function out of, some of the stuff we haven't even seen yet, and essentially make it as if it never really appeared there, which is really powerful synthetically, so you know I love that. Okay, some other just reactions that we've already seen. Remember that you have a carbonyl, you can use lithium aluminum hydride followed by water or NaBH4 to give that alcohol. And Grignards still work, and you end up making the alcohol there with the Grignard wherever it may come from. So a similar type of mechanism occurs when you have CN, so a cyano group, and we want a trace amount of acid here in this reaction. So some people use like NaCN or KCN with a little bit of acid like HCN. It does create HCN in situ, but here we have these electrons coming to attack that carbonyl. Electrons move up, and once you have that negative charge on the oxygen, it just goes and grabs that hydrogen. You don't want to acidify that oxygen first. Excuse me. And you can end up with what's known as a cyanohydrin. So we've got a CN right there and an OH there. Well, the super cool thing about that is that basically you just added a cyano or a carbon, right? And you added a CN, so you could actually reduce that to a C and H2 through Ronnie nickel, or you can use H3O and heat, and that CN will go to a COOH, which is super duper cool. Okay. So let's go move on to the Wittig reaction. So the Wittig reaction, what you do is you use triphenylphosphine, PPH3, with some form of alkyl halide. Now it doesn't have to have that, it could be like that. That's totally fine too. But essentially these two are going to react so that you end up with this intermediate that looks like this. And we've discussed what n-butyllithium looks like and what it does and how nasty that guy is in class. But basically what this ends up doing is it's a strong base, right? That's removing this hydrogen, and electrons come back. And it forms what's known as an ylide. And what an ylide means is that you've got a negative charge and a positive charge right next to each other in the same molecule. Which means that really you're under equilibrium here. You can call it either one. They're both going to react the exact same way. It's the same thing, just different forms of the same molecule. And the cool thing about it is, once you actually make this in situ, then you can add a carbonyl, and these double bonds and these double bonds combine to make those double bonds right there. And here's how that reaction works. These electrons come over, these electrons come over. And you end up with this square mechanism. And then they exchange, boom, boom. And so you end up with this guy having these 2 double bonds. And yes, you also end up with a PPH3 with this double bond to oxygen as your other reagent. Okay. And finally, we have the Baeyer-Villager oxidation. Now, this one can be a little bit tricky because it doesn't follow a standard pattern that we've seen before. You can either take a carbonyl, it can be an aldehyde or a ketone, and react it with a peroxy acid. And what this actually does, it's so cool. It can insert an oxygen right after where that carbonyl is. Now, you have to figure out though, realize that these are groups. Either one of them could end up with that oxygen in there. So, and there's a pattern to how the oxygen goes. So it specifically will go to one side or the other. So to do that, to tell which side it's going to go to, you look at this pattern. So hydrogen will move before tertiary. So this basically is saying the likelihood to have the oxygen next to it should go in this format. Okay. So here's the mechanism. First, this oxygen specifically goes and kicks out those electrons. And then see how it sort of forms almost a circle right here? This carbonyl that's from the peroxy acid comes and grabs its own tail, right? Comes and grabs the hydrogen that's right there, and electrons go back to that oxygen. And then there's this super duper crazy step. Here's what happens. These electrons fall back down from the double bond. These two things were originally attached to where that double bond was in the carbonyl over here, right? One of them, depending on this series, whichever is further that way, the bond will break to that carbon and it will go and grab the oxygen from the peroxy acid. The electrons between these two oxygens then go back here and this falls down. So here's what you end up with. If you see this part, that's what this guy ends up as. See how the hydrogen went over here and grabbed that oxygen? That's where you get the oxygen from right there. The other part is standard. So you end up with that R prime. You see it? They're the same thing as the one on the bottom there. Okay? Practice this mechanism because it's, as I said, it's a little bit tough to see sometimes. And you got to make sure you know what the product is going to be before you start through this process. Great. Thank you very much.